In question 4c, you're asked to find the solution to this equation, and we have to manipulate it such that we have the equation for the curve, and that is what you have already plotted. So starting from x squared over 5 plus 4 over x equals to 3, we see that there are already some similarities. X squared over 5, 4 over x. Now the only difference is that there is a negative 3. What we do have is a positive 3 on the right hand side. So the next step, we take away 3 on both sides, and we get 0. So now this is the same as the right hand side of our equation, and we copy down y equals 2. So in summary, this is the equation, this is the graph that we already have. And since y is also equal to 0, what we need to draw is the line of y equals to 0, which happens to be the x-axis. Therefore, to do part C, we are looking for the points of intersection between the graph that you already have as well as the x-axis, meaning find the x-intercepts, and those will be our solutions. In E part 1, you're asked to draw a line with a gradient of negative 1.5 passing through this set of coordinates. Okay, so coordinate of x equals to 2 and 1 over here. A line with a gradient negative 1.5, so it will be sloping downwards. There are a few ways we can do this, one of which is to set a value of x and to find its corresponding value of y. So for example, let a point be 0, p. Okay, so we are trying to find the y value when x value is 0. So using the formula for the gradient, so here we have 2, 1, y2 minus y1. So p minus 1 over 0 minus 2. This will give us the gradient of negative 3 over 2. So we're now going to continue to solve for the value of p. So p minus 1 is equal to, multiplied by negative 2 on both sides, we get 3. P is going to be equal to 4. What this means is that at the point 0, 4, 2, 3, 4, this is our point P. From here, draw a line down, passing through these 2 points, and it will have a gradient of negative 3 over 2. Question 6. So we have a person driving at x kilometers per hour for 2 hours and 40 minutes. Okay, so we have 2 units over here, hours as well as minutes. Subsequently, y kilometers per hour for 1 hour 20 minutes, total distance 240 kilometers. So we're going to have to make use of the relationship between distance, speed, and time. We're going to equate that to our 240 kilometers. So with our speed and time, we can find distance for the first part. So the total distance will be our speed times time, speed times the time. Here we have 2 hours and 40 minutes. So 40 minutes is 2/3 of an hour. Plus, that is the second portion, speed times the time, 1 hour and 1/3. So rewriting this, we get 8 over 3x plus 4 over 3y. It has to give us 240 because that's the total distance. So multiplying by 3 everywhere, we get 8x plus 4y equals to 720. And we can divide by 4 to leave us with 2x plus y, that's 180. And that is shown. So if you have another person, he drives at an average speed, the same x kilometers per hour, and over here we've got 3 over 2 hours, and the same y value, but this over here is 5 over 2 of an hour. And he drives 10.5 kilometers further. So doing the same thing, we find out the distance traveled in the first portion, add it to the second portion, and the total will be 240 plus 10.5. So x 3 over 2 plus y times of 5 over 2 gives us 240 plus 10.5. So simplify this, you can multiply by 2 throughout, you get 3x plus 5y equals to 501. So here we have two equations, equation number 2 and equation number 1. Solving them simultaneously is not a problem. I will not go through this. So now we're moving on to part D. How much longer will Wei take to drive 240 kilometers at the slower speed than it would at the faster speed? So we need to know what the x and y values are. In part C, we found that x is equal to 57 and y has a value of 66. So now to answer part D, using the same relationship between distance, speed and time, we want to find the time difference. So time for x will be the distance 240 divided by the speed 57. Time for y, same distance divided by the other speed. So over here we will have two different values. One is bigger than the other. So take the bigger time minus the smaller time and we'll have the difference. And after that, just make sure you convert it properly to minutes and seconds. Now question 7. The answer key at the back is not exact, and it shouldn't be because we've got pi involved in our calculations. So when I did this question using exact values, without rounding off, okay, we have the answer, the volume of the candle. This is the exact value. When you are presenting your answer, part A, you have to leave it in 3SF. But for the purpose of part C, I'm trying to find out all the exact values and see how they differ from the answer booklet, whatever is given in the answer booklet. Then in part B, the exact radius is as shown, cube root of 64 root 7 over pi. So the empty space will be 48 r cubed minus 6 times of whatever is the answer in part A. So using all the exact values, I get this. After keying this into a calculator, we have this value and round off to 1230. In your answer booklet, the final answer is given to be 1240. So anywhere between 1230 to 1240 should be correct, as long as your method is correct, and your answer should be accepted. Question A, part 1. These are the first 1, 2, 3, 4 terms. We see that this is a common difference. So you always subtract 4, meaning the D value, common difference, is -4. And we can actually use our formula to find out the nth term. So Tn is always given to be T1 plus n minus 1 times of the common difference. So our first term is 55. So Tn 55 plus n minus 1. The difference is -4. So simplifying this, 55 plus 4 minus 4n. We get 59 minus 4n. So that's for part 1. Once you have the answer for part 1, part 2 is just a substitution. T25. We have 59 minus 4 times of 25. So take away 100, we're left with -41. Now for part B. A square containing 4 numbers can be placed anywhere. Now this number is represented by n. And we see that the next number is actually n plus 1. You go down the line, you will see that the numbers are always just increasing. This 19 over here can be described as n plus 8. And this will be described as n plus 9. Move this square by yourself anywhere on the grid, and you will see that the number to the right is always 1 more than the number to the left. The number below, or rather at the bottom left corner, is always 8 more than the number above it. So for part 1, we have actually done that already. The value is n plus 9. Okay, so for example, considering 23, the number to the bottom right, you add 9 to it, you get 32. So do a quick test. Show that the difference between the products of the numbers and opposite corners is always 8. So we have to understand the question first. Product of the numbers. We're going to multiply two numbers. Which two? In opposite corners. So for example, we're going to multiply 11 and 20. So that is one product. But they are talking about the difference. So we are going to have another product in the other diagonal, in the other opposite corner. So 19 and 12. The difference between these two products apparently is always 8, and that is what we need to show. It doesn't make sense for us to multiply 11 and 12, then we take away 19 multiplied by 20. So you can take the modulus, because I'm not sure which is a larger value. No, we are sure. The 19 times, no. Okay, I got this wrong. This is 11 multiplied by 20, and the difference with 12 and 19. So I'm not sure which is larger. I can put a modulus to find the difference. There's no point doing this and showing that this is 8, because you have only shown for one example. What you need to show is for a general case, which means that numbers, but specific examples, cannot be used. We will therefore need to use a representation of the numbers. In this case, we'll use n multiplied by n plus 9. So n multiplied by n plus 9, we're going to take away the other product, which is n plus 1, multiplied by n plus 8. And we're going to find this difference. We see that this is going to give us n squared plus 9n. Take away, expand the other product. So n squared plus 8n plus n plus 8. So here we get n squared plus 9n minus n squared minus 9n minus 8, leaving us with negative 8. So what I have just done over here is to take the smaller number minus the bigger number. That is why I had a negative. Okay, so from here on, we can conclude that the difference is 8. Alternatively, if you are uncomfortable with this negative over here, what you can do is to rearrange your working to become n plus 1 multiplied by n plus 8, take away n times of n plus 9. Do the same working, and you get positive 8 this time. So the final part 3, show that the sum of the 4 numbers cannot be 260. So we're going to add everything up. So for part 3 this time, the sum is given by n plus 1, n plus 8, n plus 9. Total we have 4n plus 18. So when the sum 4n plus 18 is equals to 260, we have 4n equals to 260 minus 18, leaving us with 242. And n is going to be 242 over 4 60.5, which is not an integer. And then the same argument follows. Since n is not equals to since n is not a positive integer, therefore the sum cannot be 260. Okay, the final question in this paper that we are going through, question 10. I'm only interested in the second part. So the time taken by women, same number of women, okay, same 120, they had the same interquartile range, but they have a higher median. So let us unpack this to see what it actually means. So for the same 120 people, the median position is 260. So for the men, this is their median position. For the females, they have a higher median value. So we can do a rough estimate, maybe it is somewhere here. So this value of 50 over is definitely more than 40 over. So this is a possible median. And finding out where the interquartile range is, this being the lower quartile for the man, this being the upper quartile for the man, this is the interquartile range. And we are going, the females, they have the same interquartile range. So the difference between upper quartile and lower quartile remains constant. Well, I can shift this interquartile range to the right. So for example, over here, this is the lower quartile for the female, and this is the upper quartile for the female. So as we can see, the distance, I tried to make it the same. Okay, so now we have satisfied the two conditions. The females have a higher median and their interquartile range remains the same. So this is the upper quartile position, lower quartile position. Joining these points up, you see that the graph for the female is to the right of the males. So the description, the curve for females is to the right of males.